Introduction algorithms. All right, so last week, we talked about XML, correct?
Yes.
Okay. We talked about XML from the concept of a lot of times we have to do extraction, transform, and load (ETL) type of data processing. And that transformation is a bit of an issue, is a nice way of putting it. Transformation of data can have some serious consequences because your data itself might be stored in different formats. You have to go through and process it. The only real way to do it is brute force, going through step by step by step. So how can we make this more efficient? XML was supposed to help with that. It simplifies a lot of stuff because it's self-describing. We know what all the field names are because they're right there in the tag names or the attribute names. It's relatively simple. Everything is transmitted as text data, which is fairly consistent across all platforms, and everyone's got a way to read it. But it's problematic because it's very verbose. It's not uncommon to have data descriptions, because of the tags, take up more space than the data itself. That's a problem. Likewise, it's a lot of the XML parsers, especially if you have a lot of data, tend to be pretty inefficient. And that's because they have to be, because everything is so generic. And so people have been looking for, how do I make this better? How do I make it more efficient? How do I make it easier to work with? What can I do? And JSON came in to kind of fill that gap. And JSON was created by almost exclusively by a guy by name of Doug Crockford. And it was he started working on this back in the early 2000s, and one of his design goals was he wanted to be able to write the entire JSON definition of its language on the back of a business card. So if you think about how big a business card is, business card I had on my desk, if you look at it, he wanted to be able to just kind of write it all out on a business card. So it had to be very, very simple with how it was defined and described. So what he started looking at was, what existing technologies can we use to be able to do this? What's already out there that makes it easy? And so he came with JSON. JSON is short for JavaScript Object Notation. So the idea is that the way that JavaScript stores its data, especially its objects, why not just use that as something that we could use to store and transmit data? And so he started working on that. And to tell you how long it takes, he started working on that early 2000, like 2001, 2002. By 2003, 2004, he had a kind of a working process, was starting to get a little bit of traction. 2005, I think it was, Yahoo started to put out some of their web services APIs with JSON export. Up until then, everything was being done, that was like a web service API, was being done via XML. So now we had JSON as an alternative way. It still took until 2013 before it became a standard. And it took a couple years after that until it was published, after it was accepted as a standard. So making something a standard is not a fast process. But we got it done. And the good news is, even before it became an official standard, there was a lot of platform support for other languages. So even though JSON, has JavaScript right there in its name, there are support for all different types of applications out there. And and it doesn't matter the language. If you come up here, and if I go to json.org, just to give you an idea, json.org is the official website for JSON. Dennis Crawford has written a few books. One is How JavaScript Works, so you can kind of go look that up. But if you come down here, this is kind of how it all works itself out. And if you're really interested, I can tell you how that works later on, but we don't need to worry about that. But these are the languages that JSON has, that it can has a library, so that if you can use that library and read it and work with it. If you notice, some of them, like this is Java. Look at how many Java libraries there are for it. Same things with C and C++ and all these others. Some of these are really obvious. Obviously there's a JavaScript version that's in here. There's some information in there. You can kind of go and take a look at some of that stuff. You've got some less obvious ones that you wouldn't expect, like there's a JSON library for Photoshop. I personally did not see that one coming. Some stuff is really old, and they incorporated stuff to be able to read JSON. Stuff like Fortran. Fortran is not a modern language by any stretch of the imagination. Neither is awk or ASP, and yet those still have libraries that support it. So there's a lot of libraries out there that will support JSON and be able to work with JSON, and that's a really good thing, because it means that no matter what you're programming in, odds are you can find a library for it. And if you can't, you can create one, because the language is so simple, it's easy enough to parse out. And so that's a really, really powerful thing. You might say, well, how do you parse it out? Well, what it does is it is a lightweight data structure, but it is stored as a string. And so it works off the whole idea of being able to serialize data into a string that just happens to be like a JavaScript object that lets you work with that data and then transmit it across the two systems. The key thing is that the data must be able to be serialized, and that it must be saved as a string. So you might say, well, what is serialized data? Well, serialized data is a process of taking often a complicated or complex set of information and dealing with it one piece of data at a time. So if I have an object, if I'm thinking of object-oriented programming as a perfect example, I'm thinking of an object, I'm thinking of a person. They're going to have like a first name and a last name. They're going to have date of birth and an age, and they're going to have information like what address do they currently live at, and they're going to have information about, do they have siblings or children or parents or spouse, or any of these types of things that might be referenced. Likewise, some of that information might be things like, are they still alive? Having a date of birth is one thing, having an age is one thing, but are you still alive? Okay. All this type of data can be stored if I look at it one piece of data at a time, and that's what JSON does. So JSON looks at taking all those different types of data types, and if it's a JavaScript data type, it can work with it. So it has numbers, for example, and a number is going to be a signed decimal number that may be a floating point. Okay. So it may be a whole number, like an integer, or it might be a floating point, and it may use what they refer to as exponential notation, or something you'll see as scientific notation, where you have like 3.14 e to the negative 0.4. Okay, so it's saying, okay, yeah, it sort of looks like pi, but then we're going to move our exponents. We're going to move our decimal places. Okay, but it is not. It does not support a JavaScript notation called not a number, NaN. So NaN is if you try to store a non-numeric value into a number. It can also be like an out of range issue. It'll sometimes generate not a number, and that's a little bit of an issue. You need to be able to fix that before you go to read that data or save that data. The format's going to make no difference in notation between an integer data and a floating point number. So it's just a number. A number is a number is a number. You've got to look at and determine, okay, is this floating point or is this, an integer? And if it's floating point, is it single precision or double precision? That's actually going to be one of the things when we look at potential problems with JSON. That's going to be something we're going to look at. You can also have strings. A string is a sequence of 0 or more Unicode characters, and it's going to be enclosed within quotes. So notice that a number is not enclosed within anything, but strings are. Strings have to be enclosed within quotes. If I have a number that's enclosed within quotes, it's a string. It's that simple. The quotes need to be double quotes. Now, I have seen that some parsers will accept single quote because that's JavaScript. JavaScript can use either single quotes or double quotes. Excuse me, but in JSON, officially you need to use double quotes. The fact that it uses Unicode is kind of interesting because it means that you can put things that are non-standard text characters in there. So, for example, if you have extended text for to be able to support foreign languages that need characters that are not part of UTF-8, you can do that. It also means that you can support emojis and stuff like that. So, there is a downside to it. You have Boolean. Boolean is a true-false value. Let me say it one more time. Boolean, which is obviously going to be true or false. It is not stored within quotes. Then you have arrays. Arrays can be as small as 0 elements, or you can have multiple elements. And the elements can be of any type, and as is in JavaScript, your elements can be of mixed types. So you can have an element that's a string, and next one's a number, and next one's an object. Arrays are going to be contained within square brackets, and you are going to use commas to separate the elements. So you may notice that this means that there are no associative arrays by default allowed within the array. An object is going to be an unordered collection of name or sometimes called key value pairs. So I'm going to have, for example, if I talk about my object like I did earlier, when I had person, I might have first name, and then I'm going to have a value that goes in there. Last name, and a value that goes in there. So those two always match up. If I have a name, I have to have a value. If I have a value, I have to have a name. It's just kind of the way it works. My objects are going to be contained within my curly brace or curly brackets. Sometimes curly brackets are called braces. And I'm going to use a comma to separate each pair of data items. And to separate the data items themselves, it will be with a colon. So if you've done some C++ or CSS, you've looked at CSS, you can see how in CSS you have your braces, and then you have name value pairs separated by a colon. That's like a JavaScript object. That's not on accident, believe it or not. So that's how it uses to separate out those values. Of course, there is a special keyword called null that denotes that there is missing or empty data, no value. Null is case sensitive. It needs to be all lowercase. no quotes or anything like that around it. Okay. All of your JSON, just like in XML, remember you had that one tag that everything was stored in. JSON has everything stored inside one object, and then it breaks it down from there. So you have each object has key value or name value pairs that help to self-describe it. So the name is the field name, and then the value is the value. And my value can be of any type, which includes arrays, objects, etc., which means I can get more and more complex data. So in our example of our person, I might have address. And address is a complex data type. So I might then have an object. So I have curly braces within that. And then I might have things for like streets and city and state and zip and postal code and all that type of stuff that gets involved. I might even have multiple street items, or maybe I use the street items as an array so that I can have the different line items for my street. So there's lots of different ways I can process and store that information. And I can get more and more complicated as I go through this. What I cannot do, however, is I cannot have a reference to another element inside my JSON. So let's say, for example, I had two persons. So I had an object for my JSON data, and then I had like an array of people was my first element, and I have person one that was an object. And so I say, okay, spouse was, and I put the spouse's name. Person two, I then go through that same type process. I have an object, I put their spouse's name. Well, if person one's, their spouse was person two, and person two, obviously, therefore, their spouse was person one, I might see that their names are the same, but I have no way of saying, hey, look there, that's my spouse. Even though the data's there, even though it's clearly related, I don't have a way of showing referential information. So if I want to do that, I have to do that in my code somewhere outside of it. And I could do that by assigning maybe a reference ID. Every person gets an ID, and then I can do a lookup reference that way. But regardless of what does or doesn't happen, I can't reference that. So I either have to duplicate my values, or I have to create some sort of artificial reference key that I need to then programmatically handle on my own. So here's an example that you might see of some JSON data. Notice that my outer object doesn't get a name or anything like that. Okay, I'm going to just specify each of my name value pairs. So I have first name. Notice that my name values, my names are always strings. So notice they're in double quotes. Colon, John. Okay, so that's a name value pair. Name and value. Name first name, value John. Both are strings. Comma to say, okay, that's the end of my first field in my object. Second field, my second name value pair, last name and Smith is alive and true. Notice this is a Boolean value. So I have strings, Booleans, numbers. Here's an address. My address is that object. Okay, so boom. Here I got to deal with object. Phone numbers. Then list all my possible phone numbers I have. Notice that it's listing things like, type as well as a number. So if I think about it, for example, in my cell phone, I have my contact manager. Well, there's information as far as what the what type of phone number is I'm dealing with. It looks kind of like this. Okay, this is a work phone, home phone, cell phone, backup phone, all type of stuff. So, but I have them as brackets, and then I have my elements. My elements of my bracket for my array happens to be objects. Objects that have name value pairs. Type is home. Number is this number. Okay. All those different things. Remember, a phone number is usually going to be stored as a string, not as a number. excuse me, and how much data I want to put into this is up to me. Um, I could have and include country codes, long distance codes, all that type of stuff if I need to. Um, I have here children, which is an empty array, and spouse, which is a null value. Um, so you can see how this simple little example gives us all of our different data types. It shows one complete JSON object. If I want to have a collection of people, I might call it people and then have an array of all those people. So makes it very, very easy to work with, very, very lightweight. This is actually how most JSON is written. So every key name value pair is going to be stored on a separate line. Every time that we go to a more complicated data type, so we're a child element of an array or child element of an object, those are all indented. JSON does not care about the white space. This is just to make it easier for us because as text data, this is human readable as well as being machine readable. If you've ever tried to look at a binary file, you will know that it is not very human readable. But as text, this is human readable, so I can look at it, I can process it, I can go through it. So this is a standard way of looking at JSON data. Now, I could have it as just one big long text string. Why? It would be a little bit smaller file, and maybe I would do that if I was only sending data back and forth between two systems. But for most things, I'm going to send it and create something like this, especially if I think a person might want to look at this. Now, if we talk about some of the benefits or strengths of JSON, um, they're really easy. First off is that um, they're very commonly used in web services. A lot of web services have gone to exporting out as JSON, sometimes instead of XML, sometimes along with XML. Why is that it's very easy to parse the data, and it's also, relatedly, very low overhead. So the overhead I'm talking about is the transmission of information. With XML, remember, because it's very verbose, it takes up a lot more space. If I can send something that's one packet instead of two over the internet, that cuts my bandwidth in half. Because it doesn't matter if there's only one byte in that second packet or if the packet's full. It doesn't matter. I have to send two packets. So this cuts it way down. There's built-in web browser support, and this, remember, was designed for transmitting data back and forth between a client and a server. That client being a web browser. And it was designed to do it without needing any type of special plugins or anything like that. Back when JSON was originally constructed, a lot of times you had to do stuff either with Flash or a Java applet or something like that. Did not work real efficiently. Worked much, much better as as another format. That format just so happened to be JSON. And because of that, most modern JavaScript engines inside of their web browser have something called Json Dot Parse that goes in, takes the data, parses it out, and then puts it into a starting object for you to start to work with. Makes it very, very easy to work with. Excuse me. Now, I'm going to tell you that that's the way to do it in JavaScript. If you use other languages, that's going to be different. I'm going to show you in just a minute another way to do JavaScript parsing, which is not as effective. The JSON.parse is going to verify that it's actual JSON before it starts to parse out the data. So it's not going to accidentally run bad, malicious code inside your browser. And then finally, because it's string data, it's text data, it's very easy to be readable. It's meant to be readable by humans. It was meant to be easy to parse and process. So as far as that goes, it's a very, very simple language. Now, unfortunately, there are some problems with JSON. Nothing is perfect. And so I don't, just like with XML, I gave you some of the problems and downsides with XML. Why? I didn't want you to be caught flat-footed. I wanted you to know about it. That way you knew how to work around those issues. Okay. JSON is built as a subset of JavaScript. However, as a subset, it does not include all things. One of the things it does not include is, for example, comments. You cannot comment your JSON code. You might go, well, how important is that? I'm using it for data transfer purposes. And the answer is, well, exactly. You're transferring data. You shouldn't need to comment it. If you do, you can actually put in there API specification or something like that, and have a link to a URL as a string. So you can kind of work around that if you need to. So just something kind of to keep in back of your mind. You should never consider JSON data safe. So what does that mean? Well, early JavaScript developers would use this command called eval. And eval takes whatever data is given and tries to parse and run it. The problem is I could have malicious code inside of my JSON data. You go through, you're starting to read it, everything's fine, and then it gets actual code, eval will run that code. And that causes some real problems. So we never want to assume that JSON data is perfectly fine. Assume that it could have some malicious information inside of it that have to work around. That's why we use that Json Dot Parse method that I showed you just a minute ago. Is it handles that. It parses it and makes sure that it's only data, that there's no executable code in there. The last thing worth mentioning is your data accuracy, especially when dealing with numbers. So different languages have different ways of handling numbers. In JavaScript, you just have numbers. You don't have to kind of think about integers and floats and stuff like that. Unlike something like C++ or C# or something, where you have floating point numbers, you have doubles, you have integers and longs and stuff like that. So if I have a single precision floating point number versus a double precision floating point number, I may actually lose some accuracy because when I go to save it, I might only save out to 5 or 7 decimal places of accuracy, where a double gives me more than that, and so they get truncated because they're not considered significant digits. So you do want to be careful of some of those types of things when you're working with JSON. Especially if you're moving between 2 different systems or 2 different languages. Understand there can be some trade-offs in there. However, it is a pretty robust system. It's pretty easy to use. And next week, we're going to start focusing, sorry, I take that back up. Next class, we're going to see some examples of loading JSON data and manipulating it and writing it back out and stuff like that. Kind of like what we did with the XML, just as a process. So, but that in a nutshell is the JSON system. Any questions on that?
I'm good.
Okay.
I'm good.
I personally find JSON to be very easy to work with. Now, that part of that's because I've done a lot of web development, and so it's very easy for me. If you like, since we do have a little bit of time, I can help you decode what all these weird values are. Would you be interested in knowing what this stuff is?
Sure.
Okay. So this is Oh, I'm trying to think of what they call this. There's a special name for this type of diagram, but it shows that, okay, I'm going to store an object, and it says my object starts with a brace, and then how am I going to flow? So I can come down here and say I'm going to flow, and I have white space, and I have a closing brace. And that is just an empty object. I have nothing in it. Or I could come here and I could have white space, string, and then come down here, white space. Anytime I see white space, it's optional, colon, and a value. So this string here is my, remember everything's in a name value pair. This is my name, this is my value. And my value can be any of these types. So it could be another object, it could be an array, etc. Once I get here, I can go one of two directions. I can either go up and that's the rest of my object. I'm done. Don't have anything. Or I can come back here and follow this little path, have a comma, white space, always optional, and another name, colon, value pair. So notice that I kind of, this is all about how am I going to flow through my system, okay? And I can have splits or branches, if you would, as to which way I'm going to go, and I can always rejoin. So I always start here, I always end here. And notice I only have one entry and one exit point. When I come here with an array, same type thing, except instead of a brace, I have a square bracket, white space, and I can have a closing square bracket. Or I can come down here, have a value. So remember, my values can be of any type, and we'll see that in just a second. Come down here, loop around, comma, value, go back and forth until I want to exit out. When I get to a value, I split off. I have a huge branch. What type of value am I going to be? I can be a string, number, object, array, a Boolean value, which is true or false, or null. Notice that my values don't have white space on either side of them like I do before my string here and after my string. That's because my value has the option of having white space on either side of it. So that's why you don't see it there and how to kind of get around it. Here's my string. I come down here, any code point except quotes or slash for control characters. If I have a slash for control character, then I have to have any of these types of characters, including the /u and 4 hexadecimal digits. That is so I can do my Unicode. And then once I get done, once I go through this whole process again and again and again, however many times I need, I'm going to close it out with double quotes. With my number, I could go straight on, or I could add a negative number. If I add a negative number, I'm probably going to come down here to digit 1, but notice how everything always goes back to a single point. So I come up here, and I come down, digit. Okay, 0 to 9. Come here, digit, and I can just loop through it. Okay. Reason why I have a digit here and a digit 1 through 9 here is I have an option of having 0, but I never want to start with 0. 0 is going to be either in the middle of my digits or my only digit. I can't start with 0 unless I am 0, which is why it's separate. Set it up like this. Comes over here, possible fraction, I can ignore that. Exponent, I can ignore that. So just kind of shows you, and you can have the E and big E and lower E and stuff like that. What's a white space? Well, white space can be a space, line feed, character return, horizontal tab. Notice how everything you define is defined. So every little piece in there, you can go in and process. You might say, well, I didn't see digit, I didn't see hex. Hex was in here somewhere. Where are those? Well, come over here. Hex is made up of digits, an A through F or A through F. So different ways of kind of looking at it that you can process. Okay, and that's the basic values, for lack of a better term, of how do you kind of read these charts and how do you store data inside of JSON. When I come down here, white space, then I have my object languages. All right. JSON 2 was originally built by Douglas Crawford. That was the original JavaScript parser. It used to be on this site, and he put in it was like a free little download you could just go and download. It was like 2K, really, really small parser. And so, interestingly, one of the things he had to do is he put an alert inside of his code that says, "You're pulling data from my site. You should be pulling it from your own site. Copy this file, take out the second line of code, and then you can use the file." He had a bunch of people who were just hot linking the file from a different site. And it was causing his servers to, even though it was only like a 2K file, causing him to run out of bandwidth because it was so complicated, or there were so many hits on it and stuff. So he put that little alert message in so you wouldn't run it off of his server. Now, if you kind of look down at your address bar, you'll notice it's off of GitHub. It's not off his server. All these different examples and stuff, you can come in here. Here's C#, for example. You can do fast JSON parser. That's all part of GitHub, and you can download that stuff. We could look at some others. Cobol, that's funny.
I don't even know what is that.
Okay, so what is Cobol? That's a really good question. So Cobol is an acronym for Common Object Business Oriented Language. And it was designed back in the 60s, maybe 50s, might be late 50s. But it was designed to be a very easy to program language for businesses to use. The idea was that a manager would be able to write code. They wouldn't have to hire a bunch of really expensive programmers. That was the whole idea behind Cobol. In reality, that was not a reality. Cobol is very verbose. You have to do a lot of setup work, and you still have to understand all the logic behind your programming. So it really failed at the idea of anyone can code, but it was still used in a lot of business applications. And in fact, it still is. In fact, there was an article last week that came out. The governor of New Jersey, I cannot remember that person's name off the top of my head. The governor of New Jersey in a press conference said, of the things that we need, we need, face masks, we need ventilators, we need this, we need that. And he said, we need COBOL programmers to be able to access and update our unemployment application, because people were processing so many unemployment apps, it was crashing their backend servers. So they needed people to who could write COBOL, because their unemployment application software was still written in COBOL. They were still using this, despite the fact it was probably written 30 or 40 years ago. But all the people who worked on it originally have probably gone off and retired because it's 30, 40 years old. And COBOL's not taught in any school that I know of anywhere. But I was looking at the amount of code that's still written in COBOL, and it's staggering. And one of the really good things about COBOL is it just sits there and does its thing and runs, and it doesn't stop. It just keeps on running. So as long as you've coded it good, it just keeps on chugging away. And so people are like, hey, you know what? We're running a bank off of this software. We don't want to go and rewrite this in C# where it might not work, or we got to spend years debugging this. And so instead, they just let it's kind of the, if it's not broke, don't fix it. Now that works until it gets to a place where you can't support it anymore. So should you go off and learn it so you can find it and have an easy job to do it? Maybe it, it doesn't hurt to know it. Whether you would want to find a job maintaining code that the last person who worked on it's been retired for 10 years, I don't know. And where do you go to learn it? It's like I said, I don't know of any modern university that teaches it. IBM has supposedly put out some training materials for free because they were one of the big people behind COBOL originally. They put out some training materials to teach people how to do COBOL. But like I said, I still don't know if I would want to go in and do that or not. But that's what COBOL is in a nutshell. COBOL, Lisp, which is here, which is another weird language, and Fortran. Those three programming languages were three of your earliest programming languages, period. I think Fortran and Lisp were the first two, and then COBOL came shortly after that. But those are three programming languages that are very, very old. Excuse
How
me.
about MATLAB? I did MATLAB.
Yeah, MATLAB's a lot more recent, but I saw it had a language for it. Yeah.
Yeah.
I mean, some of the stuff like Lotus script. I mean, I don't know anyone who uses Lotus, let alone Lotus script. Same thing with Fox Pro, RPG. RPG is another language very similar to COBOL. There's still libraries to do it. So, I mean, it still is being used. And if you want to move data from one old system to another, you can do it. Some of it's built into, like PHP, it's built into PHP 5.2. I'm assuming it's also in PHP 7. I don't know for a fact, but I'm assuming. Cold Fusion, I don't know where that's being used at all anymore, but apparently it is at some point. So, anyway, just some interesting stuff in there. Okay. Any other questions?
I'm good. I'll just have questions for the CA project.
Okay. Give me a second. I'll pause and record.